Hello, guys. Welcome back. So, your assignment last week was to basically look at testing sites, how they're set up, and what's going on, and how we can further plan for those testing sites, and how we can incorporate UAS into the planning for those testing sites. So, with using our drones to figure out where we're going to do COVID-19 tests, we can survey a general area, take a map of that area using 2D or 3D mapping features with our drones, so we can get high resolution maps, get proper measurements of distances in the area, volume measurements, figure out the traffic flows in the area and how we're going to need to reconstruct the traffic to best fit those areas because they could potentially be high traffic areas. So initially we'll use the mapping function with our drones to determine appropriate locations. So we're going to have to estimate the potential size of the site and its ability to handle vehicles and personnel. So in an area like Fort Smith, there's a lot of people in that area, so we're probably going to have more than one test site set up. However, depending on where we choose to set up the site or sites, that can really determine a lot. Because things you're going to look at is where you're going to house all the workers, all the people that are there providing the test, support personnel such as EMTs that are on standby in case somebody has a medical event there, in case workers get heat exhaustion from being in tents all day, wearing all this extra personal protective equipment, and dealing in potentially hot temperatures with all this. So I have to figure out that. All the different work areas, public traffic lanes where you're going to have the cars coming in, cars going out, staging area for cars, any structures that might already be there that you could utilize. So like I mentioned previously, a good place in Fort Smith to do this, and just off the top of our head, would be Ben Garin, because it's a big drive-through system. There's several pavilions already set up around there. There's bathrooms that we could easily make for staff bathrooms, designate pavilions so you don't have to bring in a whole bunch of tents. That could really make things flow easier. And the Department of Emergency Management has an office right there by Ben Garin, so it would be fairly simple at that in that instance. After you figure out your site, you're going to need to figure out the security needs and concerns that can be rapidly evaluated. How are you going to secure the area? Keep people from walking in anywhere and everywhere, contaminating parts of the scene that don't need to be contaminated. Again, traffic flow into and out of the sites can be evaluated to determine how many lanes can be accommodated. If you're using Ben Garin, you're going to have one, maybe two lanes. If you've got one-way traffic, it's going to be, you could have up to two lanes. If you're just doing one-way traffic to an in and out type thing, then you're only going to have one lane for each. Standby people areas that people can be directed to, and in a lot of instances, testing sites will only have so many tests that they can do a day. So there's going to be screening processes that go on there, even though there's been a pre-screening that happened before they got sent to the testing site. There's going to be further screening once they get there to determine those who are most likely to be symptomatic. So they're using the test appropriately to those who are most likely to have it take the test. And they might have some people staged so they can take the test if they get to that point. And then once your test site is set up and operational, you can use the maps to double check everything. You could check another map, or you could take another map set to make sure everything's going well. See if there's problem areas that aren't being very efficient, where you could change some stuff around, minimize your personnel, stuff like that. So again, some pros with this are mapping flights are simple. They're very autonomous. You don't do a lot of hands-on stick flying with a mapping flight. And that's because most of it's done through software. So you're going to get a software like Pix4D or Drone Deploy, and you're going to open up that program on your computer, figure out what you need, download your maps, download it onto your iPad or whatever device you're controlling your UAS with. And then that will pretty much tell your drone what type of pattern it's going to need to fly, whether it's a grid pattern, circle patterns, anything like that. And then it'll tell your drone what type of pictures it's going to need. So it's probably going to do, if we're using a fixed wing, they're going to be mostly nadar pictures. If we're using a nadir, which is pointing straight down to the ground. If we're using a multi-rotor, then you'll probably take a few sets. It'll probably fly a grid pattern, a couple grid patterns, cross grid. It'll take a set of nadir pictures, which are going straight down, and then it'll come back through and take another set of pictures that are maybe 30 degrees. Depending on if you're just doing orthomosaic. If you're doing orthomosaic, it'll probably all be nadir, which that's going to stitch together and make pretty much a Google map, a real-life Google map in high resolution. So you get a really good, accurate picture. If you're using more of a 3D mapping option, then it's going to go through and it's going to take those set of pictures at 90 degrees and it's going to come back through, maybe at the same altitude, maybe at a slightly different altitude, and take pictures at a 30-degree angle. Maybe even do a third run with pictures at a 60-degree angle. And what it does with all those pictures at different angles is it creates a point cloud from the GPS information from your drone. So the software computes all that data with the GPS information, your picture information, and it stitches it all together. And instead of just getting an orthomosaic from your nadar pictures, then it starts to build layers into that, and that gives you a 3D picture. So you can get a model off of that. Some of the software, like we just this last week while y'all have been gone, I went out with Morrison Shipley, civil engineers and surveyors, and we did this over Northside. So we've got an orthomosaic map of Northside, and our next step is to render a 3D model of Northside. So we'll be able to see our high school during all the construction and stuff in real time, how it looks, and we can pull it up on the computer. I can send you a link, and you could take a virtual tour through Northside with all the construction and see what the buildings look like on the sides, what it looks like from on top, all the way around at 360 degrees. And then going on from that, we can convert that 3D file into an STL file, which that would allow us to put it into like Cura and scale it down, and then we can make our Gmode file and stick that into our 3D printers, and then we can print an actual 3D model of Northside High School or of the test site that we're trying to do. So if we need something tangible that we can put our hands on and we can see it and look at it and show it to other people, that this is what it's really going to look like, then we can do that, which is super cool. So your end product on this can be very accurate and ready for fairly exact measurements and of distances and volume, because it's all using GPS, depending on the software and the drones you have as to the accuracy. If you're working with like a civil engineering company and you can get set GPS points, then that just makes it even more accurate. It allows for further global information system integration, and areas can be flown again for change analytics. So having all that stuff going through there could change the way things are going. It could just change the environment around the area because of all that change. So you could look at that and figure out if there's something you need to do because of those changes from what you had planned. Cons is the product requires computing time depending on the complexity required. Some of the mapping solutions are pretty quick, but the quicker it goes, the less accurate it typically is, because you got to give something to get something. And so depending on the size of the mapped area, it could take several hours to compute, and it's going to require a third-party solution like Pix4D or Drone Deploy that I mentioned, or others. And typically, like anything in the aviation world, the UAS drone world, you get what you pay for. If you're going to pay $5 for a $400 fix, you're going to get $5 a use out of that $400 fix instead of $400 worth of use. So that's how that goes. A little bit outside of the scope of the assignment, but still goes into the 3D mapping aspect. A lot of places are using the mapping feature for homeless camp evaluations. So they're using drones to kind of survey or run surveillance on the homeless camps to figure out what they're doing during all this and try to help figure out the social distancing aspect. But with this COVID-19 has raised a lot of further concerns about homeless camps. So using those 2D maps, they can create a map, a layout of what the drone or the homeless camps are looking like right now, how everything's set up and established in those. And then from that, they can make pretty much make a plan on how they're going to deal with anything they need to there. If they're going to have to go in for medical attention, they're going to set up a staging area for EMS. If the police are going to have to go out there, they're going to set up staging areas to go and figure out how they're going to get into where they need to get into. So that's just a little extra tidbit for you there. Going into this week's assignment, we're going to look at using drones for community patrol in the public safety aspects. So the use of drones for normal patrol duties can be extremely beneficial in continuing to safeguard a community against crime and other issues, as well as assist in public safety during times of crisis. I don't know why I put a T on the end of crisis, but public crisis. So as we've talked about a lot, since I come from a law enforcement background, you know that's an area I go to quite a bit in all my stories and discussions. But they due to Corona-19 or COVID-19, they're being used even more by public safety. So some perks with that is they can assist law enforcement while they're doing routine patrols. Out at the beach, they can assist a lifeguard by looking for people that are in a bad situation and can get supplies out to them, stuff like that. So I'll be giving you an article that goes along with that, more or less in the security realm. And then I need you to let me know what type of drone could be good for stuff like this. Any special attachments we're going to need, any payload considerations, some pros and cons, just like we've been doing for the last 4 weeks, guys. Again, I'm always here for you if you have any questions. I hope the rest of your classes are going well. I hope you're having a relatively good time away from school. I know it sucks for me being out of the classroom because I do miss the interaction with you guys on the daily. But I'm always here for you. You can always reach out to me, phone, text, or email. And I'm more than happy to help how I can. Or if you just need to talk to somebody different for a while, I'm always happy to talk. So be watching for my videos this week. This is your assignment. And I'll talk to you guys later. See ya.